So we said that a cluster is going to be obviously a bunch of machines or virtual machines, which we'll do because we have one Delenn server. And within that cluster, you're going to have a bunch of worker nodes, but a small number or just one will be a control plane, which is going to manage the rest. So you will actually kind of talk to the control plane, not really talk to the nodes themselves. And what the nodes are going to run is kubelet, which is a daemon that runs in the background to make sure the node is talking to the control plane. So that's the way the communication works. And so if nodes disappear or come online, they'll either fail to keep the heartbeat, and so control plane will notice it's gone, or when it comes online, it'll like introduce itself. So add to that, we've got a thing called a deployment. This is probably the most like relevant part of Kubernetes. This is where you're saying what to launch. They use the word spec a lot. You're going to put spec in a definition file, a YAML file. This is just, you're going to give a specification for what the deployment has to look like. So what are the things that are going to run, what the ports are, how our application works, and so forth. So that'd be called the spec. We'll get to pods in a second. So deployment is about pods. A pod is a group of containers. So container is from before, like a Docker container. Group of containers, and you would often think of like, well, I just want to launch one thing, but you might also actually have things that are kind of on the side relevant to the main container, or, you know, it's like a database or something, but here's the website container, or here's a container that's doing logging or something like that, or doing periodic alerts or whatever. So they would all be in the same pod. It's kind of, this is the deployment I want to launch. I want to have all these containers running. So it could be a group of them, like helper containers. And it would have a single IP once it's launched. This is what Kubernetes is going to manage for you. We saw before that when you run containers, you're going to run it on your OS. And so you would talk about the ports, but not really the IP addresses. Whereas here, the pod is going to associate one IP with all those containers. So each container inside may have different ports, but or just one main port, but the pod will have one address. And so I'll say containers probably have ports associated that will be associated with that IP. And pods can also include volumes, just like we had volumes for containers for Docker, meaning they're not really in the container, right? That's the point. The container is the image. It should not really have much data that persists. So if you want to either share data or have it persist, you're going to attach a volume to the container. And in Docker, that's kind of just stuck on the side. For pods, the pod itself will have the volume, and the containers inside will see that volume if you need something like that. So only shared within the pod, and volumes can persist after the pod is destroyed. That'd be a persistent pod or persistent volume versus ephemeral. So normally it's ephemeral, and that would mean they only persist as long as the pod does. But so I guess it's important to say that ephemeral volumes disappear when pod disappears. But, you know, we're at several layers of abstraction now. There's things containing things all over the place here. There's deployments containing pods, pods containing containers, containers containing applications that are actually running, and pods are also containing volumes. So within the pod, if a container restarts, the volume, ephemeral or not, will, I guess I worded this funny, but it's still there, right? When the container restarts, because it died or whatever, it's going to see the volume as it was just a moment ago. So if you've added files to it and the container dies but comes back again, the files are still there. As it was before the container died. So volumes inside pods attached to the containers, also inside pods. And there's lots of types of volumes, a lot of interesting ones, including AWS Elastic Block Storage. So we can go create a big volume, and that, of course, be a persistent one, and have our various applications in the containers in the pod talk to Amazon and save stuff up there. Of course, we can run this in Amazon too, and I want to explore that Friday, most likely, under their EKS. I have to sign in again, but you make a cluster up there. So there's also secret type of volume. A lot of times you're going to have containers that have applications that need to know some configuration data or even like passwords or API keys or whatever. So you got to send those to the applications somehow, or not even necessarily secret stuff, but there's configuration maps also if it's not really secret stuff, but somehow you got to provide configuration data, like which users are the admin users, or which IP addresses to talk to if you're talking to an API, or what the token is, or whatever. So these would take the form of a volume that is put in the pod, and then the containers can see the volume and see if it's like a secret one. It won't actually be on the disk, like it won't persist like that, but they'll be able to read the data out of that one and use it when they start up or whatever the case is. So you'll see secret volumes floating around, and that's what they're for. A container, like we said many times, is just a Docker container, or anything that's like Docker. And you would build these the same way as before. Create an image, and you want to persist the image in a registry. And just refer to it and pod spec. I'll show you that. There's lots of kinds of registries. You can have a registry on your own machine. You can have a registry in Amazon. You can have a registry at Docker Hub or whatever. So that's the basic idea with how things run. There's a deployment that specifies which pods you want. And by which pods, I mean like they don't have names yet or anything. You're going to create a pod right there in the same file. So the deployment says, let's make a pod that has these containers. And of course, the containers then will say, this is my image, which has been uploaded somewhere. So the actual code that runs has been predefined in an image. So you say, I want a container with this image. I want a container with that image. I want these well, I'll talk about ports in a second. So just say, I want a container with this image and a container with that image, and I want a volume that they can both see. That's what's in my pod. And then the deployment says, use that pod that I just defined. And we can even say like, start 10 of them. So when you do want to access the code that's running, like a Flask application or whatever, you got to somehow get to it. And that's now a tricky affair if you're going to build it from scratch. This has been done for you, which this is what Kubernetes is providing. Not only how to start and stop pods and containers and all that and keep them running and notice that they're gone and start new ones, but also getting into them and actually getting to a port that has the running code. And that's tricky because if their pods and the containers inside are starting and stopping and replicating and changing which machine, which node they're on and all that, and there's load balancing and so on, things are constantly changing, like IP addresses and even the ports, because you got these tunnels and so on. So you saw before with Docker, when you launch a container, you'd say, let's expose this port. If the Flask application is on port 5000, well, I want that to tunnel to my local port 80 or something, and then the world can access it. But if the container is in a pod, part of a deployment, you can have multiple deployments, of course, and that pod's on some node, then we don't really know where it is. So we need to let Kubernetes manage all that, because as it's going to take away pods and produce new pods or whatever, it's got to keep track of how things are accessed. So that's known as a service in this terminology. Service is where you say, I want to connect to these containers, or really these pods, through certain ports. Again, you have a spec that says which pods have which services, i.e. ports. No, everything's going to be accessed through a port. Like I've said, which pods actually have the running service will change, possibly. Service is specified, since you're not going to say which pod, because you don't really have control over that, you're going to specify what's known as a selector, kind of like a label, to pick out what it is you're talking about. So you want to connect this port to this label, which is going to be some pod. Okay, so we'll have to do that too. And then finally, all this interaction with the so-called API, the Kubernetes API, which is, the definition of how all these things relate to each other and what they're supposed to do when you ask for something to be done, is all going to be done through kube control on the system that, the system that can talk to the control plane. So however that's established. If this is running in Amazon, for example, see how they do that, but there's going to be some way that we say that's where the cluster is. So kube control, it's a command line tool that we use to talk to Kubernetes. All right, let's get into that. And there's a neat intro kind of cluster setup. It makes one node, a virtual machine kind of thing, called Minikube, that I want to show you. And then I want to do actual, it's not actual, I guess it's going to be a virtual machine, but a cluster on Delenn that's multiple virtual machines. So more realistic, I guess. But Minikube's kind of cool, has a nice interface. You can actually go, I haven't tried these launch terminals, but I think they let you kind of interact with Minikube through the website if you don't want to install it. But you could look at the install instructions here for your OS. So I've got that on Delenn. I've got the dashboard open, it's here. So you could see like what the nodes are. It makes the one node. The pool or the pod CIDR is, the pattern for the pod that's going to make for the IP addresses. It'll change the 0 here because that 24. So all these are fixed. And just info about the node itself, which would be Delenn. Actually, I'm not sure if Minikube's in a container or in a VM. I forgot to look. What was I think it said. I guess it could do either. Okay, well, we can see if we run Yeah, I guess it's a container. Minikube here. Okay. Their example. So we'll just go through their example real quick. Kube control create is how you're going to create a deployment. And this is just a super simple one. So you just put all the things on the command line. You say, I want to call it this, and the image, it'll make a container with that image is this public one, which just, I think, replies with whatever data you send to that web service. So we'll do this. So Minikube's running already. Oh, not that. Now it's quick because it actually has told a worker node to start creating that container. So if you then say kube control get pods, it is actually running. So it's because it already had the image, it already had downloaded it. There's a lot of things you can get. The documentation for Git is here. And actually, these are the parameters for Git. So the things you can get would be, if you look at API resources, these are all the things that the API knows about. And you can get these things. Most of them you're not really going to look at, but there are things like pods, pod templates, the nodes, and so on. So let's look at the nodes actually, and services and secrets and so forth. Kube control get, what did I say? Nodes. There's that Minikube node. And yeah, so there's no templates. Anything else? Events. Here's the deployment. So here I said, let's see, already here. So started a replica set, meaning how many of these pods do I need to make? And because we just made from command line, it's just going to default to one. So it made one such pod, created the pod right there in a replica set of one thing. Then it started the pod, which caused the container to start. There's one container inside the pod. And it seems like the order is not what I thought. So, and then at this point, it grabbed the image, but I found it had already downloaded the image. So actually, I think I'm reading it backwards. Gets the image, creates a container, starts a container, and then makes the pod. So what we want to do next, when we last run, let's look at deployments. Should be the one. And what you can do now when it's running is, let's look at its definition. So we want to edit deployments. This is what it came up with. Most of the stuff you would not actually specify if you're typing it from scratch, because a lot of it's default. But the spec for the deployment, and we'll make one ourselves in a minute here. So it's the kind of thing that we're looking at as a spec for deployment. There's metadata, which is the parts you would probably have yourself would be the label or the name. Then the spec follows, and you say, I want run replica, and the template for the actual pod is here. So give it a label so that when you say, when we're replicating, what label are we looking for? And the template spec, so the actual definition of the pod, it's going to have these containers. Here's the image. So again, a thing like image pull policy, if not present, that's assumed. We could change it here, but give it a name if you want, and Should it restart if it dies? So it's really all defaults except the image. And its current status is this. So if we come in and do, let's see if we change replicas to, it's been edited. See, it's now scaled it. It created another pod, it created another container, and created another pod and scaled it. So now you have two. So that is this so-called declarative syntax where you say, no, actually, I want this. And then when you quit Vim, because we did edit, it says, okay, so let's look at what we want, what they just saved in the Vim, in the template file, and what we have. And that difference, it'll have to then migrate the current situation to the situation that we've asked for. So let's see what happens if we go back to one replica. Scaled down replica set to 1 and deleted a pod. Terminating, cleaning up the resources. Right, so there's an example of this declarative mode with replication. And you can change other things too, but then let's try this kind of a neat thing. Let's try this. Output. And so we'll go back to 2. And then here's the output. And I think I should have saved that. Sorry. Arrow. It's in Vim now. So what's the format for saving that? Output formats and save config. If true, the configuration will be saved. Otherwise, the annotation will be unchanged. But I want it to export it. Let's just save it from Vim. Oh, it's being weird. I'll wait until we write our own. Not sure how to export that. Does anyone know who's used kube control know how to get the template to save? Let's see. So that's editing. Okay, I'll look it up later. You can also directly adjust some of these things. So the scale command, kube control scale, you can say how many replicas you want here without going through the edit process. So for example, you got to say what you're scaling. So it says deployment and hello node. Look. See, it's creating pods and changing the replica set. So let's look at what the dashboard shows. So now we still have the same node, but pods are here. And what do we see about the pods, where it's running, on which node, and it's events and conditions. What the controller is. It's in a replica set, so that's the kind of controller it is. And what the containers are. That's the image for the container. Here's the events. So replica sets, you're going to see the 3. And these are the 3. And the events for that replica set being modified a bunch of times. Creating, deleting pods. And here's that deployment. I don't have any services set up. I'll do that in a minute. And I'm not really using secrets, but there's always a default secret with the exact certificate stuff. Yep. All right. Make a cluster for ourselves, virtual cluster. Found a Git repo that uses Vagrant. So Vagrant, it's kind of like Ansible. Well, it goes with Ansible often. Vagrant will allow you to say, start these virtual machines. It's like, in a way, like Kubernetes, or maybe like Docker with Docker Compose, but it's not making containers, it's making virtual machines. And actually, I think you can connect Vagrant to Docker just to confuse things. Yeah, Docker provider. But anyway, we're going to use it for, what are the options for that? Yeah, so it's quite similar to Compose as far as I can tell. We're going to make virtual machines, and you get to say what the memory size is and all the normal stuff you'd say for a virtual machine, the CPUs and so forth. And then you could also make them see each other on the same network. And what Ansible would be used for, if you do want to go that direction, is Vagrant has an option for what's the provisioner. So Ansible is a provisioner, meaning it sets up an existing machine. And so you would put a reference to Ansible there. And this Git repo, they just used shell scripts to provision. And what the shell scripts need to do is put the kubelet daemon up there and other Kubernetes stuff. It's going to make a couple nodes, worker nodes, and then the control plane. So the Vagrant file, we're not going to do anything specifically with Vagrant, but it's another one of those tools that people use to set up machines. Vagrant also, by the way, I think can connect to, I thought it would connect to AWS also, but so it's more virtual machines like Hyper-V if you got a bunch of virtual machines on like a server. So it says provisioner is shell because it's going to be below just some shell script. It's going to make a master node, which is the control plane with 2 gigs memory and 2 CPUs. And it's a Ubuntu virtual machine. Vagrant has a registry like Docker does for machines, common machines, and what its IP is. And then for nodes 1, 2, and 3 in a loop, make a node with that name. Also 2 gigs, 2 CPUs, same Ubuntu, and the IP address will be whatever the node number is, plus 11. So 11, 12, 13, or yeah, it starts 0. Whereas the control plane is 10. And then the steps to provision is to restart kubelet on the worker nodes, and then they all get this common stuff. Just, you know, they know each other's IP addresses, and the Docker's installed and the right packages are installed. So it's nice to have, because this kind of stuff you'd want to run on your cluster, on all the machines on the cluster, to get them configured with Kubernetes, but it's all going to be done for us. And you would run Vagrant up to have those all get created. And that's been done. So if we look at Vagrant status, should see that they're there. I'm surprised it's hanging. Okay, there they are. They're actually running in VirtualBox. Supports other things though. So to get into one of them, like Kubernetes, Docker is going to, or sorry, Vagrant's going to make these virtual interface cards for connections into the virtual machines, the bridge connections. So the best VBoxNet there at the bottom, the best thing to do is just use Vagrant to get in to one of the machines that it's controlling. Okay, so we've logged into the virtual machine, and now I want to make, we have that Quotely application from before, so let's make a pod with that in it. And that was Docker stuff. We came up with a Docker file. So, you know, we're using Kubernetes, but we do need to make an image that will be in the containers. So the Docker file is Python with Flask, because that's in requirements, and it starts the app, and the app is the quote thing. It listens on port 5000, which we'll want to know. The app is just, you give it position 0, 1, 2, 3, 4, and it gives you back that letter. So let's put this in a pod. Before we do that, we'd actually have to upload this. We do a build, give it a name. And so I made an account here on Docker Hub. And so this is the name of the image. I have one name for, there's a space for all my images, but I'll put a tag on it that is the app. So I did that, and then I did a Docker push. Now it's up here for everyone, so you can, this is what I did, and then you could pull it, or you could just refer to this name in your use of Docker, or if you make a pod or whatever. So let's make a pod. Now I don't want to do it here actually, because then I'll have to put it on the master, because if I'm running here, this is just the LAN, it's going to go into Minikube. That's the Kubernetes connection that's active. I want to do it in the VM of the master for my virtual cluster. So I've already got it here, but let's make it again. All right, so we need to specify the API version that has the commands that we're going to use for pods. Make a pod here. So we're not going to make a deployment yet or a service, the other two things that would matter to us. Let's just make a pod. And it'll just have that container in it. So this is YAML, by the way. YAML is pretty straightforward. You can just put JSON in here if you want, but you can also use this more YAML style syntax. So what we have here is key value pairs. So we're building a map here. And actually, we're going to put documents, like multiple YAML files on top of each other. So we're going to use dashes to separate them. This is key and value. And if you want like a map inside your map, so 2 keys to get to a value, you just indent. And as long as you just keep lining them up, they're all still inside that main, like they're all in the same map or dictionary. Now here's another sub dictionary. And so that's metadata about the pod, basically the name. And the spec will be, we got to say what the container is going to be. We can have multiple containers, but we're just going to have, actually, let's have multiple containers just to show that there are 2 things running in the same pod. So the first container will be an Nginx basic install, just listening on port 80 or whatever, and just shows the front page. Like, hey, you've installed Nginx. What we just introduced here is a list. In YAML, a dash starts a list. So you can do like this or whatever. But often you're going to see a map in a list. So that's what we're going to do right here. Introduce the colon, which makes a map. Just make up a, sorry, I don't want a sublist. Just make up a name. There's another key. So this image is going to be, from Docker Hub. Make a container with this image. It's nice to list the ports, or a list, but they're actually just informational in this pod definition. We still have to specify later how to get to them with a service. But we'll say the container is going to expect connections on port 80, but it's just informational. And a second pod or container, which will be the Quotely, say service. And its image is going to be the one I uploaded. And we'll say you can expect port 5000 to have the There's our pod spec. Pretty straightforward, actually. Kube control here will manage the, was it 3 nodes that we made with Vagrant? So we'll say, well, first let's see what's going on. Oh, I've actually already started them. Let's get rid of them from before. Delete. Let's look at the deployments actually. So let's delete that. Just to make sure. Let's get rid of that. Okay, we're starting from scratch. So we'd say kube control create, and then you just give it the file, because whatever's in the YAML file, we stated we're creating a pod. You can create other things in the same file. So create just says, give me the spec or specs, and I'll create all those. So it's been created. And notice it's a pod because that's what we said in the file. And then when we look at pods, there's the pod. It's running because it already grabbed the image. It would have shown that it's building it if I didn't already have the image. You can get more info about that pod if we describe it. Which node it's on. It's on node 2, apparently. I didn't decide that. And there's the IP of the pod. And I'm not really connecting the ports to myself, so there's no host port. And these are the images and so forth. And then default secrets. What I want to do now is actually get into that node 2 and poke around. Let's get out of the master node into the node 2 where this is apparently running. And it's not super obvious, but if you do Docker PS, you can see, in fact, it is there. Python app py, that's what we just started. Other stuff is Kubernetes management. Oh, the Nginx is also the thing we started. So that image ID 98C, is that listed somewhere? I'm not sure. And that's all I wanted to do in there, just to show that it is Docker running in that node. The other nodes, they're not going to have that because this thing's not been replicated yet. So it's just regular Kubernetes stuff. If we look at the services, we're going to see that we don't have a service set up for that pod. So let's make a proper deployment now. Let's get rid of the pod, because then we're going to make a service for that. Delete pods. I called it. I got to go back to the master. It's a little complicated because I got the VMs being a cluster. Delen's not really talking to them, but the master node is. So yeah, again, we don't have that service set up, but we do have the pod. We want to get rid of it so that we can make a proper deployment. Right, so the change in the spec will change to deployment kind of spec. Not sure why it's taking a while. All right. My connection. I don't know if it's Delen or must be Delen. All right, it just told me that my connection's unstable. So let's stop here. We only have a minute. We'll run
I was going to say your video is kind of like stopping and your audio is also like cutting off.
For how long?
It was just recent. When you started saying, this is taking too long, that's what happened.
Okay, well, good. That's not a problem then. So we'll just do the command to start, or we'll define the spec for the deployment in the service on Friday, and we'll do the command to start it. But again, like I said, I want to put this on Amazon if at all possible. So I'll research how to do that. And bring any questions you have about the current homework. And then obviously next week, we're going to have some homework related to this. And I want to use Amazon, and we'll have to start thinking about pricing, because when we do replication and so on, it could add up. I don't think it's going to add up that much, but it finally switched. I ran that command minutes ago. But still, we got to be somewhat aware about how much we're going to spend when we create a cluster. All right, so come back Friday for all that.
Professor, I was going to mention I might not be able to join on Friday because that's when my flight is. So it's like literally at like 5:30, so I probably not going to be able to join into the class.
That's fine. I mark in the file things like okay when students already told me, so it'll be fine. And you can catch the video.
Okay, thank you. Have a good day.
You too. See ya.